What I want to do in this video is talk a little bit about plate tectonics. Plate tectonics. And you've probably heard the word before, and or you might be somewhat familiar with what it discusses. And it's really just the idea that the surface of the Earth is made up of a bunch of these rigid plates. So it's broken up into a bunch of rigid plates, and these rigid plates move relative to each other. They move relative to each other and take everything that's on them for a ride. And the things that are on them include the continents. So that literally is talking about the movement of these plates. And over here, I have a picture I got off of Wikipedia of the actual plates. And over here you have the Pacific plate. Let me do that in a darker color. You have a Pacific plate. You have a Nazca plate. You have a South American plate. I could keep going on. You have an Antarctic plate. It's actually, obviously, whenever you do a projection onto 2 dimensions of a surface of a sphere, the stuff at the bottom and the top look much bigger than they actually are. Antarctica isn't this big relative to, say, North America or South America. It's just that we've had to stretch it out to fill up the rectangle. But that's the Antarctic plate, North American plate. And you can see that they're actually moving relative to each other. And that's what these arrows are depicting. You see right over here, the Nazca plate and the Pacific plate are moving away from each other. New land is forming here. We'll talk more about that in other videos. You see right over here, in the middle of the Atlantic Ocean, the African plate and the South American plate meet each other, and they're moving away from each other, which means that new land, more plate material, I guess you could say, is somehow being created right here. And we'll talk about that in future videos, and pushing these 2 plates apart. Now, before we go into the evidence for plate tectonics, or even some of the more details about how plates are created, and some theories as to why the plates might move, what I want to do is get a little bit of the terminology of plate tectonics out of the way. Because sometimes people call them crustal plates, and that's not exactly right. And to show you the difference, what I want to do is show you 2 different ways of classifying the different layers of the Earth, and then think about how they might relate to each other. So what you traditionally see, and actually I've made a video that goes into a lot more detail of this, is a breakdown of the chemical layers of the Earth. And when I talk about chemical layers, I'm talking about what are the constituents of the different layers. So when you talk of it in this term, the topmost layer, which is the thinnest layer, is the crust. Then below that is the mantle. Actually, let me show you the whole Earth, although I'm not going to draw it to scale. So if I were to draw the crust is the thinnest outer layer of the Earth. You can imagine the blue line itself is the crust. Then below that you have the mantle. So everything between the blue and the orange line is, this over here is the mantle. Let me label the crust. The crust you can literally view as the actual blue pixels over here. And then inside of the mantle you have the core. And when you do this very high-level division, these are chemical divisions. This is saying that the crust is made up of different types of elements. Its makeup is different than the stuff that's in the mantle, which is made up of different things than what's inside of the core. It's not describing the mechanical properties of it. And when I talk about mechanical properties, I'm talking about whether something is, so mechanical properties are whether something is solid and rigid. Or maybe it's it's so hot and melted, it's kind of a magma or a kind of a plastic solid. So then, this would be the most brittle stuff. If it gets warmed up, if rock starts to melt a little bit, then you have something like a magma, or you can view it as like a deformable or a plastic solid. And when we talk about plastic, I'm not talking about the stuff that the case of your cell phone is made up. I'm talking about it's deformable. This rock is deformable because it's so hot and it's somewhat melted. It kind of behaves like a fluid. It actually does behave like a fluid, but it's much more viscous. It's much thicker and slower moving than what we would normally associate with a fluid like water. So this is viscous. This is a viscous fluid. And then the most fluid would, of course, be the liquid state. This is what we mean when we talk about the mechanical properties. And when you look at this division over here, the crust is solid. The mantle actually has some parts of it that are solid. So the uppermost part of the mantle is solid. Then below that, it has a kind of, the rest of the mantle is kind of in this magma, this deformable, somewhat fluid state. And depending on what depth you go into the mantle, there are kind of different levels of fluidity. And then the core, the outer layer of the core, the outer core is liquid because the temperature is so high. The inner core is made up of the same things, and the temperature is at even higher. But since the pressure is so high, it's actually solid. So that's why the mantle, crust, and core differentiations don't tell you about mechanical solid, whether it's solid, whether it's magma, or whether it's really a liquid. It just really tells you what the makeup is. Now, to think about the makeup, and this is important for plate tectonics, because when we talk about these plates, we're not talking about just the crust. We're talking about the outer rigid layer. And we talk about that. Let me just zoom in a little bit. Let me just zoom in. Let's say we zoomed in right over there. So now we have the crust zoomed in. This right here is the crust. And then everything below here, we're actually talking about the upper mantle. So we're talking about, we haven't gotten too deep in the mantle right here. So that's why we call it the upper mantle. The upper mantle. Now, right below the crust, the mantle is cool enough that it is also in real solid form. So this right here is solid mantle. And when we talk about the plates, we're actually talking about the outer solid layer. So that includes both the crust and the solid part of the mantle. And we call that the lithosphere. The lithosphere. When people talk about plate tectonics, they shouldn't say crustal plates. They should call these lithospheric plates. Lithospheric. And then below the lithosphere, you have the least viscous part of the mantle, because the temperature is high enough. The temperature is high enough for the rock to melt, but the pressure isn't so big that the pressure isn't so large as what will happen when you go into the lower part of the mantle, that the fluid can actually kind of move past each other. Although it's still pretty viscous, it's still a magma. So this is still kind of in its magma state. And this fluid part of the mantle, we can't quite call it a liquid yet, but over large periods of time, it does have fluid properties. That essentially the lithosphere is kind of riding on top of, we call this the asthenosphere. Asthenosphere. So when we talk about the lithosphere and asthenosphere, we're really talking about mechanical layers. The outer layer, the solid layer, is the lithosphere. The more fluid layer right below that's the asthenosphere. When we talk about the crust, mantle, and core, we are talking about chemical properties. What are the things actually made up of?